Hey class, Unit 7 is all about probability. And while sometimes probability can be tricky, I think that you'll find that the homework questions are fairly easy. You just have to make sure you do the reading and that you follow the examples in the reading. Make sure you attend your live seminar so you get a chance to work through a lot of different examples during the seminar time. But I did want to pick a few types of problems that you're going to run into and just go through it in a video so that you have the opportunity to watch it at your own pace and pause and work it out, pause and play and stuff. So it won't be a long video, but it will definitely be one that I think that you'll find helpful for some of your homework questions. So what you see on your screen is an example of a two-way table. It's a two-way table because you see the ages over here and you see the genders here. So it's basically a table that addresses two qualitative variables and looks at the relationship between them. But frequently, we will be asked to calculate probabilities related to these two-way tables. So this is actually a problem from your textbook, from the exercises in, I think it was section 4.2 maybe. All right, so the first question, find the probability. So we know we're going to be looking for either a decimal answer between 0 and 1 or a simplified fraction answer. And because of the messy numbers, I'm going to go ahead and put them in decimal form. And I can't remember how many places the question wants you to round to, but we'll go ahead and just round to like 4 decimal places. But make sure you're careful about checking that when you're doing your homework questions. Find the probability that the driver, and this is just assuming you're going to pick one driver at random. So find the probability that the driver is male and 19 or under. So it's going to be really important to pay attention to words and or. Like, oh gosh, let me get a thinner pen. So this one has the keyword and, this one has the keyword or. Those are really important words in probability because we deal with compound events and sometimes we need to add outcomes together. Sometimes we might need to multiply outcomes together. With two-way tables, there's actually some shortcuts on what you can do when you come across the words and or the word or. So when we see the word and, like we do here, then we need to realize that and implies that all of these events apply. So I've got to first find all the number of people all the number of drivers in the table who are both, because of the word and, who are both male and also 19 or under. Okay. I have to find out how many fit both of those categories. They have to be male and they also have to be 19 or under. Well, here are the male numbers, but some of those males are not 19 or under. In fact, the only ones that are both male and 19 and under are these right here. And we knew not to even bother with the female numbers because it said that the driver had to be both male and 19 or under. So females does not apply to this particular question. So the number of drivers who are both male and 19 or under is the number 4746. And then we're going to divide it by the total number of people in the table altogether because it just said choose a driver at random. And so our denominator needs to be the total number of drivers. So therefore, at this point, I would just take my calculator. Sometimes they'll tell you how many total there are in the question, but in this case, it did not. So I'm actually taking my calculator and just adding up all 6 of these numbers right here. So that's what I'm doing right now. And we will get a messy fraction, which is why I was saying if they give you the option of putting a decimal answer, then you would want to do that. All right, so I'm getting the denominator once I add up those 6 numbers of 15,747. All right, if it allows a decimal, that's going to probably be easier. So that means I would go ahead and take my calculator and just do 4746 first, divided by 15747. Press enter, and I am seeing 0.30139, which means if I'm going to round this to 4 places, then that number's in the 4th place, but I look to the right and I see a 5 or bigger. That means I'm going to round that number up. So don't forget that decimal point, 0.3014 would be what I would put for that. All right, the next one. Find the probability that a driver is age 20 or female. Now with the word or, then you don't have to look for the people that are both. The people that are both would satisfy being age 20 or being female, but with the word or, all that has to be true is that the person either has to be age 20 or either has to be just female. So it's very different from the word and. And so mathematically, we just add up the people who are age 20 plus the people who are female. And we don't worry about trying to look for those people that are both, because that is not the way the word or works. The one thing you do need to be careful about with the word or when you're dealing with these two-way tables is making sure you don't double count people. And I'll show you what I mean by that. Okay, so let me actually erase what I've got right here just so we can clear things out. Oops, I didn't mean to take the whole thing out, darn it. Let's see if I can go back. Oh, no, I don't think it's going to let me go back. Let me go. I tell you what, let me go ahead and clear the markup. Yep, there we go. All right. So let's see where I was. Oh, yeah. So age 20 or female. So what I'm going to do here is first find all the people who are age 20. Well, that's this 1625 number and the 1553. And since it's the word or, and so these people don't have to also be female. They just either have to be age 20 or they have to be female. So I'm going to take all the people that are age 20. Well, that's 1625 plus the 1553. Those numbers reflect all the people that are age 20. But or people that are female. So mathematically, I'm going to add, because of the word or, I'm going to add the females. But what we don't want to do is double count this number that's already been included right there. So when you add in the females, because of the word or, you just make sure you add in the females who have not already been included. So that's just the 4517 right here at the top, and then the 1627. And then once again, the denominator would be whatever the overall entire total is when you add up all 6 numbers. Now, I'm not going to work all of that through just because it's tedious for me to sit there and put that in the calculator while y'all are waiting for me just watching the video. But it's the same thing I did earlier where I would add up all 6 of these numbers, and whatever I get there would go in my denominator. Then I would, mainly to make sure that I don't get out of the order of operations in my calculator, then I would next go ahead and add these 4 up. That would become my new numerator. And then, of course, I would add the 6 numbers up in the entire table. That would be my denominator. And then my final step would be just to divide so that I could get a decimal answer, as long as the question allowed a decimal answer. All right. Let me clear that part out. Okay, and then the last one. Find the probability that a driver is at least 20 years old. Well, the words at least and at most are often tricky for people. You have to realize that the word at least, I like to give kind of a scenario you can relate to. Suppose your instructor said, I want all of my students to get at least a 90 in my class. I mean, that's kind of a common type of phrase. I want all of my students to get at least a 90. Well, that does not mean the instructor is telling the students that he or she wants them to get less than a 90. If he or she says at least a 90, they mean 90 or higher, that I want you to get 90 or higher. So at least really means this number or higher. At least 20 years old means 20 or older. So when I go to my table, and this part did not refer to anything about gender. So that means you take all the people who are 20 or older, which would be these people who are 20, as well as these people who are older than 20. So you would add up those 4 numbers, and that would be the top number. And then, of course, add up all 6 numbers, and that would be the denominator. And then you can divide out. So at least means 20 or higher, 20 or older. If it had said at most 20, then it would mean 20 at the most or anything less than that. So at most 20 would mean 20 or younger. It's tricky. People often get them mixed up and do the opposite of what they should be doing for those words. All right, so definitely you're going to see two-way tables in your homework. In fact, numerous questions involving two-way tables. And just be careful about the words and or, and remember that they mean something very different when you're calculating probabilities. The other question I wanted to go over, and the main reason I wanted to go over it is just because of the messiness of the calculation. So I want to give y'all a website that might be helpful with regards to that. All right, and that is going to be, let me go see if I can pull it up. All right, so that is going to be a question like this one right here. Let me pull this down a little bit. In ALEKS. Find the probability of getting 2 face cards, which include a king, queen, or a jack, when 2 cards are drawn from a deck, but notice it says without replacement. Without replacement. So what that means is you're going to pick your first card, but not put it back. So that when you go to pull your second card, since this problem is talking about picking 2 cards, when you go to pick your second card, you've got to remember that the number of cards in the deck is no longer a 52. It's going to be 51 because you picked your first card and left it out. You did not put it back in. So it's just when you get these problems without replacement, it's sort of tricky because you got to remember that the numbers are changing every time you pick another card. Now, if it's just 2 face cards, that's not really that big of a deal because let's suppose okay, so here's kind of how you set it up. You would look at the first card, probability of being a face card, and then you would look at the second card and figure out the probability of it being a face card. And since the problem had said, find the probability of getting 2 face cards, then the implied word is and. Because that would be saying, okay, well, if I get 2 face cards, that means my first card was a face card and my second card was a face card. And the reason I'm emphasizing that word is because and means to multiply when you're dealing with probabilities. Now, when we did the two-way table, we did not have to worry about multiplication because the numbers were already laid out for us, that we did not have to worry about formulas. We could just pull numbers straight from the table. But in a case like this face card problem, you got to realize that and is implied and it means to multiply probabilities. So when you go to pick your first card and you're finding the probability that it's a face card, there's a jack, queen, and king for each of the 4 suits. So 3 face cards times 4 suits in the deck, that's 12 total face cards in a standard 52 card deck. All right. Then multiply, I'll just put a dot, and the probability that the second card is going to be a face card, well, there's 1 face card fewer now because the first card was assumed to be a face card, and there's also 1 total card fewer. All right. And then y'all will go through and multiply and simplify your fraction. Now, what makes this one really tricky, this particular example is not that tricky, but let me show y'all something. All right, notice this question says enter your answer as a fraction. In other words, you do not have the option of putting in a decimal, which is usually easier because you can just use the calculator and press buttons and divide out. But when it says you have to enter your answer as a fraction, that's much trickier, okay? So you'll have to work on simplifying your fractions. Now, the one that I would be doing the 2 face cards is not really that big of a deal, but I know that somewhere in this question bank, this is mainly from me previewing the questions, that there are some of these that might say find the probability of getting 8 face cards or 9 face cards or 10 face cards. And that's what I want to go through with y'all, because that's going to get really crazy in terms of the size of the fraction numbers, and the numerator and the denominator. All right, so let's just go ahead and let me clear this. And let's suppose it was 10 face cards. I'm going to make it really crazy. 10 face cards. All right, well, what that would mean is that your first card needed to be a face card, and your second card needed to be, and your third card and your fourth card, all the way up through your 10th card needed to also be a face card. Because if you pull 10 cards and they're all face cards, that would mean the first is a face card, and the second one is a face card, and the third one is a face card. The reason I'm emphasizing the word and is because we're going to be multiplying all these little probabilities together. Imagine if I put little dots. All right, but I need to first find the probabilities. So the first card being a face card is 12 out of 52. We explained that earlier. The second card being a face card is 11 out of 51, and hopefully you're going to see the pattern. After you've already picked 2 face cards, there's now only 10 face cards left and only 50 cards left in the deck. And this is because the problem had said without replacement. And then so forth, 9 out of 49. And I think you're probably seeing what I mean when I said, whoa, these numbers are crazy messy. That's why I wanted to go through this with you in a video. I didn't want to leave any of y'all out there for about 3 hours trying to figure out how to simplify all this junk. So I hope everybody's watching this video that's working on this question, or that's getting ready to work on this question. I hope you watch the video first. All right. And I hope I'm getting near the end. I got to check, because when I talk and try to do math at the same time, my multitasking is sometimes bad. All right. So up top, we've got 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. Looks good. Each time it reduces by 1 because the number of face cards is getting lower and lower and lower as you pick more and more face cards. The denominators, 52 total cards to start with, but then decreases by 1 card each time. So 52, 51, 50, 49, 48, 47, 46, 45, 44, 43. Looks good. All right. Now, if you put, you know how we multiply fractions? We go straight across the top and multiply, and straight across the bottom. Well, if you put all of these numbers in the calculator, you're going to get a huge numerators and denominators that you are not going to want to try to simplify the fraction by hand, or I would not think you would want to. You'll probably be working for quite a long time. So here was my little tip. If you remember canceling common factors out with fractions, that's going to be my suggestion, all right? So like, say the number 52. That's the biggest number even on the whole screen here. So if I know a number that goes into it evenly, then I'm going to go ahead and cross cancel. And I know that 4 goes into it evenly. If you did not know that, then you can cancel some other things and it will still be helpful. But I know that 4 goes into 52 13 times. So what I'm going to do to help myself get this thing, get all this mess simplified, is I'm going to scratch the 4 out because it goes into the 52 13 times. So it's kind of like canceling the 4 out to a 1, but I don't need to write in the 1 because when you multiply by 1, it's not changing anything. And 4 goes into 52 13 times. All right. Then I move to the number 51, but honestly, right off the top of my head, I may not know numbers that go evenly into 51, so I'll skip over that. Then I see a 50. Well, I know that 10 goes into itself 1 time, and it goes into 55 times. So what I'm doing here is trying to make all these numbers much smaller so that I can deal better with the simplifying process. The number 49, I know that 7, so I get to cross the 7 out, goes into 49 7 times. The number 48, I know that 8 goes into 48 6 times. The number 47, I don't know of anything that goes into that right off the top of my head. The number 46, don't know that. The number 45, 9. So notice I'm trying to pick big numbers and get them crossed out. 9 goes into 45 5 times. 44, 11 goes into 44 4 times. And I don't know any numbers that go into 43. All right. So what I have left is a 12 right here, a 6, a 5, and a 3. That's it. Everything else got scratched out, which is nice. On the bottom, I now have that 13 that I had gotten. The 51 is still there. 5 is there. A 7, and I'm just going straight across getting these numbers, is there. A 6 is there. Need more room for all these numbers. 47 is there. 46 is there. Another 5, a 4, and a 43. But I can still do some more scratching out. All right. So I know that 6 goes into 6 one time. So I don't even need to put the 1. I know that 5 goes into 5 one time. And let's see, anything else? 3, I think, does go into 51 17 times, but you might not know that. But if you do, it would be nice to realize that 3 goes into 51 17 times. All right, so you get it down to where it's a little more manageable. I only have a 12 up top. It would have been okay even if you'd had 2 numbers up top. You at least got it reduced down to much fewer numbers. So what I'm going to have to do in the bottom now is multiply all these numbers that are left, but at least they're not huge like the initial ones were. So 13 times 17 times 7. I'm just going 13 times 17 times 7 times 47 times 46 times 5 times 4 times 43. In fact, I just realized I could have crossed out the 4 and the 12 a little bit. But that's okay. So I multiply those, and I'm still left with a very, very big number. But imagine if this is still this big, imagine what it would look like if I had not done this nice little trick first. All right, so that's what I have left. Now, we know it can still be simplified because both the top and bottom number are even numbers since they end in 0 and 2. At this point, I'm going to suggest a website that I found, and it's really one of the few that I found that could handle a number this large. Even my TI-83 or TI-84 calculator was having trouble with some of the big numbers and was giving me scientific notation answers, which is not acceptable for this question. So the website that I found that you might want to use for this question, and y'all, by the way, this question number, just so you'll be heads up on the lookout for it. Oh gosh, did I already get rid of it? I think it was question number 10. I honestly can't remember off the top of my head, and I've already let that thing go, I think. Yep. So anyway, it's either question 10 or 12 for y'all to be on the lookout for. So the calculator that I want to recommend is rapidtables.com. And you just go to calculators and math calculators, and you go down to where it says fraction simplifier, which is really in the S's because of simplify. So fraction simplifier, and I'm going to open that up. Now the numbers that we were dealing with were 12. So let me go ahead and I'm going to write this number down. 287 636 80 40. Okay. So the numbers that I've got to put in here are 12 and then this huge number 287 636 80 40. And it's going to look like it didn't take it all in, but if you kind of keep scrolling back, it did take it all in. You just can't see all of the numbers. Such a big number. And then you press calculate. But what you have to be careful about is not to look right here where you naturally would look. And that's because it's not going to show enough numbers. The numbers are so big. You need to come down here and look at your answer right there. So that in Alex, you would put in a 3 in the numerator, and then the denominator would be 719092010. Crazy big. but at least this website, and let me move this up so you can see it, rapidtables.com is what you first go to, and then you just click on calculators, math, and fraction simplifier. So that should at least help you a little bit when dealing with just these crazy huge numbers, so you don't spend hours and hours just trying to simplify the fraction. Personally, it's not my favorite question, but I realized it was there, so I just wanted to make sure I made a video that gave you a resource to possibly use to help you with the simplification. All right, y'all go get that probability stuff done.